Hi everyone, and welcome to the second unit of our transmission line discussion. So now that we have learned a little bit about what a transmission line is, we're going to, in this section, take a closer look at what this equations that govern the transmission line look like and what their solutions look like. And furthermore, when you're done with this set of discussions, you should be able to understand the key parameters. So the characteristic inductance, capacitance, the characteristic impedance of the transmission line, the propagation velocity. You should be able to identify and interrelate these variables. One tricky thing that I think is easy to forget when we introduce this is, remember, when we talk about the inductance or capacitance of this transmission line, it's actually the inductance per unit length and capacitance per unit length. So keep that in mind. But I want you to know what the differential equation looks like, know the general concept of what the solution, the traveling wave solution looks like, and if given either the transmission line geometry, which is what we'll talk about during the latter part of this unit, or if you're given the equations themselves, that you can extract those key parameters, again, inductance, capacitance, characteristic impedance, propagation velocity, and interrelate them to each other. And the bottom line is that you need to know how this wave behaves and how transmission liney your setup is, because once you know the velocity and how long it takes for your changes to propagate, that's the key piece of information you need to be able to compensate. So let's dive right in.